let's understand a couple of properties and theorems on inverse trigonometric functions. Okay, under that, see, in trigonometry, remember you had a relation reciprocal of sine theta is cosecant theta. Same thing we have here also. Okay, the rule is sine inverse of x is equal to cosecant inverse of 1 by x, or sine inverse of 1 by x is equal to cosecant inverse of x. Okay, now guys, this one will prove. Okay, it's a very simple proof. We'll quickly prove this one. What we'll do, say y is equal to sine inverse of x. Okay, then sine y is equal to x, right? Now what do we have? Cosecant y will be equal to 1 by x. So what do you have y as? Y is equal to cosecant inverse of, so sorry, not cos inverse, cosecant. Cosecant inverse of 1 by x. So what is y? Sine inverse of x. So we get sine inverse of x is equal to cosecant inverse of 1 by x. Now this is true for every reciprocal function. Okay, so this is one. The other ones are also true. In the sense you have cos inverse of x is equal to secant inverse of 1 by x, and tan inverse of x is equal to cot inverse of 1 by x. Clear with this? This is the first property in inverse trigonometric function. So when I say first one, we are looking at this one. This is this one, and this one. All three together makes the first property in the inverse trigonometric function. Clear with this? Let's go for the next property now. The next one is about the negative values. We have already seen that in the last video. Correct? Still, let's do this one. All right. See, the first one is, if you have sine inverse of minus x, this is going to be minus sine inverse of x. But remember, x value has to be within the domain and range of the inverse trigonometric function. Clear? Sine inverse of minus x is equal to this one. Now let's prove this one. Proving part is very simple. We have, say, y is equal to sine inverse of minus x. Then sine y is equal to minus x, or next what do we have? X is equal to minus sine y. Correct? X is equal to minus sine y. Now what are we trying to do? Sine inverse of minus x is equal to minus sine inverse of x. Correct? This is what we are trying to do. So now what exactly we are going to do? X is equal to minus sine y, correct? Now this is going to become, see the negative sign there. See the negative sign. You know that sine of minus theta is equal to minus sine theta, right? So I might as well do x is equal to sine of minus y. So now what do we have? Sine inverse of x is equal to minus y. Correct? Sine inverse of x is equal to minus y. Now take the minus sign that side. You will have minus sine inverse of x is equal to y. But what is y? Y value is sine inverse of minus x. So minus sine inverse of x is equal to sine inverse of minus x. We got the value. So easy. Fair enough? This is the proof. Now, the other two functions, whatever we have so far, or whatever we have, are, the first one is tan inverse of minus x is equal to minus tan inverse of x. We have already used this one. Cosecant inverse of minus x is equal to minus cosecant inverse of x. This also we have done. We have used this one. So this is first one. These two are the next two. This is the second property in inverse trigonometric function. Understood? Let's go for the next one. This also involves negative values, but then the other three trigonometric functions. Okay, the first one is cos. Guys, I have already explained it to you in the last video. That means we have used this in one of the problems. But then in the last one, I gave you only two of these. Actually, there are three of this in the negative scale, in the negative numbers. I had given you two of them. Let's discuss all the three in here. All right. See, the first one is cos inverse. Cos inverse of minus x is pi minus cos inverse of x. We need to prove this one. Again, what we do, we'll take y is equal to cos inverse of minus x. So cos y is equal to minus x. Correct? Or x is equal to minus cos y. Now this we can write it as cos of pi minus y. Because cos of pi minus theta is minus cos theta, isn't it? Now what do we do? So you take it. Cos inverse of x is equal to pi minus y. But now what do we have? Take the y this side. So y is equal to pi minus cos inverse of x. What is y? Cos inverse of minus x is pi minus cos inverse of x. This is the proof. Okay, this is the proof. Now, the other two trigonometric functions, which shares the same way of getting the negative values. So the first one is cot inverse, which we have already discussed. Cot inverse of minus x is equal to pi minus cot inverse of x. The other one is secant. Secant inverse of minus x is pi minus secant inverse of x. This is the first one, which is most commonly used, and these two are the other two. Clear? This is the third property in the inverse trigonometric function, and this property involves negative values. Clear? Let's go for the next fourth property of the inverse trigonometric functions. This property involves the complementary angles or the complementary functions, to be more precise. What is the complement of sine? Cosine, which is the cos. So this inverse trigonometric function rule or property involves sine inverse and cos inverse. Okay. See, the first one what we have in this particular case is sine inverse of x plus cos inverse of x is equal to pi by 2. Again, the whatever the inverse trigonometric function you are doing is within the range and domain. So what you have is sine inverse of x plus cos inverse of x is pi by 2. Let's prove this one. See, what you know is that take y is equal to sine inverse of x. Then what you have, sine y is equal to x. Correct? Now, sine y can also be written as cos of pi by 2 minus y. What is cos of pi by 2 minus theta? Sine theta. Now what you do? Take the cos inverse that side. In the sense, pi by 2 minus y is equal to cos inverse of x. Or, what do you get? Pi by 2 is equal to y plus cos inverse of x. But what is y? Sine inverse of x, isn't it? So pi by 2 is equal to sine inverse of x plus cos inverse of x. See? So whenever you have complementary functions, the addition or the summation of those two will always give you pi by 2. So the other two are what? Tan and cot, secant and cosecant, correct? So the formula, or more likely the result, is going to be tan inverse of x plus cot inverse of x is equal to pi by 2, and secant inverse of x plus cosecant inverse of x is also equal to pi by 2. These two and this one. Very, very important result. So you guys have learned four properties of inverse trigonometric function, correct? In the next video, you are going to see there are a couple of more properties like this itself. You guys are going to see that in the next video.